Okay, so if you can turn to page 10 of your packet, we're just going to discuss margin of error. And the margin of error is really just, I mean, you could just read it right here at the top. It's a measure of how spread out the sample means are relative to the value of the actual population mean. So, all right, let me just kind of, for our purposes here, the margin of error is going to be equal to 2 standard deviations. And this is the formula we use here to find the margin of error. It's just equal to 2 times, and this is how we're going to find a standard deviation. So within this formula, we have a P, a Q, and an N. The P is the proportion of successes. A lot of times in the problem, they're just referring to what the mean of your samples is equal to. Q, right here, it's P times Q. Q is just equal to 1 minus P. So for example, if P is equal to 0.25, then this would be 1 minus 0.25, so that would be 0.75. And then N is just your sample size, so the sample of size N. All right, now, since we're talking about, for our margin of error, and since we're talking about 2 standard deviations, if you take the mean and subtract off 2 standard deviations and add on 2 standard deviations, that's going to contain about approximately 95% of the data. So we call that the 95% confidence interval. All right, so let's take a look at what they might ask us for with margin of error, and let's apply our formula. All right, so at the bottom of this page, number 13 says, a candidate for political office commissioned a poll. His staff received responses from 900 likely voters, and 55% of them said they would vote for the candidate. The staff then conducted a simulation of 1,000 more polls of 900 voters, assuming that 55% of the voters would vote for their candidate. The output of the simulation is shown in the diagram below. Okay, so basically what's going on here is, they didn't want to assume that 55% of the voters would vote for the candidate just based on this, I guess, one poll that they took. They want to kind of examine the results to see what shot this candidate really does have of winning. So based on that one poll, they ran a simulation 1,000 more times. And when they did that, I mean, sometimes the candidate wound up with 52% favorable outcomes. Sometimes it wound up with 58% favorable outcomes, and so forth. So you see that 55% is right here in the middle, because that's going to occur the most, because that's what they were assuming when they did these simulations 1,000 more times. But if we can find the margin of error, what that's going to do is that's going to give us kind of an idea as to how far below the mean and how far above the mean the data might fall if it were pulled a different time. Okay, so anyway, the question, if we just look at the question, says, given this output and assuming a 95% confidence level, the margin of error for the poll is closest to. All right, so let me first just write down our formula for margin of error again. I mean, it's right there at the top of the page, but the margin of error is equal to 2 times the square root of P times Q divided by N. Okay, so our margin of error is going to be equal to 2 times the square root. Now, P stands for the proportion of successes, which in this case, we're assuming that to be 55%. Okay, so I'm going to replace the P with 0.55. Always change that percent to a decimal. And then the Q, we know, is just 1 minus 0.55. So Q is equal to 1 minus P. So 1 minus 0.55. So that'll give me 0.45. Okay, so we'll replace that with a 0.45. And then we're going to divide that by the sample size, which they say right here is 900, right? There were 900 voters. So if you plug that into your calculator, 2 times the square root of all that, you're going to get approximately 0.03. Now, that's all we really needed to know to answer this question, because all they wanted you to do was find the margin of error. But just so we can go into a little detail about what that means, if you want to figure out where the majority of the data falls, the majority of the data is going to fall within 2 standard deviations of the mean. So if you take the mean, we call that right here the 95% confidence level or confidence interval. If you take the mean and subtract off as well as add on 2 standard deviations, that's always going to give you the 95% confidence interval. Now we know our mean here is 0.55. And then this margin of error that we just found, this is 2 standard deviations. So if I take 0.55 and subtract off 0.03, 0.55 minus 0.03 is 0.52. And if I take the 0.55 and add on 0.03, that'll give me 0.58. So what that means is this interval right here is where approximately 95% of the data should lie. So if we look from here to here, approximately 95% of our data should lie within that. All right, if you flip to the next page, let's take a look at number 14. Number 14 says, the school newspaper at a large high school reported that 120 out of 200 randomly selected students favor assigned parking spaces. Compute the margin of error and interpret the resulting interval in this context. All right, well, we know, first of all, our formula for margin of error is 2 times the square root of p times q divided by n. Okay, so let me bring down margin of error equals 2 times the square root. Now, p is the proportion of successes, or what we expect to occur. Now, if we know that 120 out of 200 students favored assigned parking spaces, well, let's kind of do that off to the side. 120 divided by 200 is 0.6, right? So 60% of students favored assigned parking places. So that's going to be our P. That's what the expected outcome is. Now, Q is going to be 1 minus that. So 1 minus 0.6 is 0.4. And we're going to divide that by our sample size, which is right here, the 200. All right, so if you plug that in your calculator, you get about 0.069. So the margin of error is approximately 6.9%. Okay, so I'm going to box that off because that was the first thing they said, compute the margin of error. Then they say to interpret the resulting interval in this context. All right, well, we want to find when they say the resulting interval, they're talking about the 95% confidence interval. Or, in other words, the mean plus and minus 2 standard deviations, or the mean plus and minus the margin of error. Okay, so we know our mean is 0.6, and we just found our margin of error to be 0.069, and I mean, I'm just approximating here. So if we want to find our 95% confidence interval, 0.6 minus 0.069 is 0.531, and 0.6 plus 0.069 is 0.669. So this right here is, let's see if I can fit this. I'm probably not going to be able to. The 95% confidence and then interval. You know what? I can't fit it there. I'll just put it here. Sorry, there's like a little bar at the bottom of the screen where I can't write there. Okay, so what this means, because they say to interpret the resulting interval, like this is the interval, but what does that mean? What this means is that we are 95% confident that the proportion of students who favor assigned parking spaces lies in this interval. All right, I'm going to type that out, because if I try to write on this, no one's going to be able to read it. Okay, so there we go. So you could try out number 15 on your own. That one's really similar to this. And we're going to skip down to number 16. We'll do that one together. Okay, number 16 says a sampling distribution of sample proportions for a specific study has a mean, which they're calling P, of 0.32, and a sample size of 50. The standard deviation, or the standard error, of this sampling distribution is 0.066. What is the margin of error for a 95% confidence level? All right, well, actually, based on what they give us, we could do this one of two ways. If you want, here's the quick way. Since we know that margin of error is equal to 2 standard deviations, we can just do 2 times, and they give us the standard deviation is 0.066. All right, so that'll give us 0.132. And that's it. That's what they wanted. They just wanted to know what is the margin of error for a 95% confidence level. So that's where we get the 2 standard deviations. All right, if you wanted to, just put or. If you wanted to use the formula, they give you the information for that as well. You could do 2 times the square root of P. Well, P would be 0.32. And then 1 minus 0.32 would be 0.68. And we're going to divide that by the sample size, which they say right here is 50. So if you plug that in your calculator, you also get 0.132. So either way you want to do it is fine. Okay, I'm looking ahead right now. On the next page, actually on the next 2 pages, 17 through 20, you guys should definitely be able to do that on your own. So I'm just going to jump right to number 21. Okay, so 21 is a little bit more reading. It says, 55 students attending the prom were randomly selected to participate in a survey about the music choice at the prom. 60% responded that a DJ would be preferred over a band. Members of the prom committee thought that the vote would have 50% for the DJ and 50% for the band. A simulation was run 200 times, each of sample size 55, based on the premise that 60% of the students would prefer a DJ. The approximate normal simulation results are shown below. Okay, so what they did was, because they took a single survey of 55 students and came up with 60%, they wanted to run a simulation of the same, of the same example here 200 times, just to see, how spread out the different results could be. So Part A says, using the results of the simulation, determine a plausible interval containing the middle 95% of the data and round all values to the nearest hundredth. So basically all they're asking you to do is they're asking you to find the 95% confidence interval, right? They want the middle 95% of the data. So if we want to find the 95% confidence interval, we're going to use the formula we've been using. It's basically just the mean plus and minus the margin of error, or the mean, let's see if I can fit this down here, the mean plus and minus 2 standard deviations. Now, luckily, they give us the mean and the standard deviation right up here in the diagram. Okay, here's our mean and here's our standard deviation. So let's just take them and just plug them right in. So the mean is 0.602 plus and minus 2 times the standard deviation is, oh, look, same as the last one, 0.066. Okay, so if we were to do, I'm just going to break this off into 2 separate, the lower bound of our interval and the upper bound of our interval. If we were to do 0.602 minus 2 times 0.066, that's going to give us 0.47. So that's the lower bound. Okay. Then if we were to do 0.602 plus 2 times 0.066, that gives us 0.734. So this right here is our interval that contains the middle 95% of the data. Now, they do say they want us to round all values to the nearest hundredths, to the nearest 2 decimal places. So the middle 95% of the data lies in the interval between 0.47 and we're going to round that to 0.73. Okay, and you could see, 0.47 occurs like right there, and 0.73 occurs right right there, so it's kind of hard for me to line up on the point. So this right here is the middle 95% of our data, or the 95% confidence interval. Part B says, members of the prom committee are concerned that a vote of all students attending the prom may produce a 50-50 split. Explain what statistical evidence supports this concern. Okay, well, we found out that 95% of the data lies in the interval between 0.47 and 0.73. Okay, this right here is called our 95% confidence interval. So anything that lies in that interval is a very likely outcome to happen, okay? We call that a usual occurrence. That could happen, anything within that interval could easily happen. It's just anything outside that interval that we don't expect to happen. I mean, it could. That's where our outliers fall, but we don't expect that to happen. Okay, so, since they're concerned that it may produce a 50-50 split, they have a right to be concerned because 50% falls within our 95% confidence interval. So what we could say here, I'm going to type this out again so you could read it, but I'm going to say we are 95% confident that the percentage of students who would prefer a DJ lies in the interval between 0.47 and 0.73. Since 0.50 lies in this interval, it is plausible to get a 50-50 split. Okay, actually I lied. This is handwritten instead of typed, but here we go. All right, so what I'd like you to do on your own right now is I would like you to try number 22. 22, again, is a lot of reading, but, it's kind of similar to what we did here. And we will go over these, the ones that we skipped the next time we meet.